of convergence of the following power series. This is from chapter 11. Did I get, yeah. So we got the sum 1 to infinity. Of -1 to the k times x to the k over 3 to the k. All right, we need to use one of our tests on there. With all those k exponents, which one do you think is most appropriate? Root test. When you ratio test is if you have a k factorial in there. Then it's always ratio test. All right, let's use the root test. So we take the limit kth root of absolute value, -1 to the k. I'm showing lots of detail. Don't have to write the -1 in there. And the reason you don't have to is because it's an absolute value and we're going to take it out now anyway. Okay. All right, so the absolute value does away with the -1 to the k because absolute value will make it always positive. And the kth root cancels out these k exponents. Now, I didn't say we could get rid of absolute value, I only said we could get rid of the -1. We still need the absolute value. And the reason why is because it's possible x could be negative. Okay? All right, by the root test, this series will converge when this limit is less than 1, right? Now, this k is the variable of the limit. There isn't a k there, is there? So this is all treated as a constant. So this simply equals absolute value x over 3. And again, this will converge when this is less than 1. So we need to solve that for x. Well, the absolute value of 3 is 3. And so we have here multiply by 3 on each side. And we have here absolute value of x is less than 3. And then from high school algebra, when absolute value is less than, it could be between 3 and -3. That gives us an interval of convergence, maybe not the final one, but it's going to converge between -3 and 3, not including -3 or 3. So do we know our radius of convergence? Yes, our radius of convergence is 3, right? That's half of that interval. So we can put 3 in there for that. But now it wants the interval of convergence. Well, the problem is, if we put either -3 or 3 in for x, we get 1, don't we? And by the root test, when this limit is 1, the root test is inconclusive. So at this point, we don't know whether it converges or diverges at -3 or 3. So now we have to test it at the end points. So let's start with -3. We'll let x equal -3. That gives us the sum. K equals 1 to infinity. -1 to the k of -3 to the k over 3 to the k. So, what is -1 to k and this negative to the k? What do they do to each other? They cancel out because they're both being raised to the exact same exponent, the k. That means they will have the same sign. They're either going to both be negative or both be positive. And whenever we multiply with the same signs, we get positive, don't we? So this is equal to the sum, k goes from 1 to infinity, of 3 to the k over 3 to the k, because those cancel each other out. Now, 3 to the k divided by 3 to the k is 1. What does the sum of 1 do? Does that converge or diverge? You're going to be adding an infinite number of 1s. 1 plus 1 plus 1 plus 1. Is that going to converge or diverge? Diverge. And you can prove it with the divergence test. The limit as k goes to infinity of 1 equals 1. If that limit is anything other than 0, it diverges. All right? So it diverges. That means we do not include -3 in our interval of convergence. We do not include it. Okay. So now we need to let x equal +3. We need to find out what happens on this end. So that gives us the sum as k goes from 1 to infinity. -1 to the k would be 3 to the k over 3 to the k. Those cancel each other out, and we have -1 to the k. Well, use our divergence test again. Does that limit approach a specific value? No. As we put in integers, it's going to jump back and forth, +1, -1, +1, negative. It does not approach a specific value, does it? So this limit does not exist. D in E. If that limit is, the only chance it has at converging is if that limit equals 0. That doesn't guarantee it converges, that just gives it a chance. If that limit does anything other than equaling 0, diverges. If that limit does not equal 0, diverges. That's not 0. So, diverges by the divergence test. So it diverges at -3, diverges at +3. That means our interval of convergence is with parentheses -3, 3. If it would have converged at either one of those endpoints, we would have put a bracket on that one. Let's check that. divergence, negative 3, 3. There you go. So any questions here?
Did you do the proofs as well, or do we have to also do the proofs? Or we can kind of tell that they're
I mean, those over there? Yeah. Technically, yes, you need to do that. Yeah. If all you do is tell me it diverges at x equals negative 3, how do I know you just guess? You know, or see it on your neighbor's paper or something. Yeah, you need to show something basic. Yes, sir.
When we get to this part, so, like, do we have to do that research or can we do like how you said, we use our intuition to
No, you need to do the divergence test. That's what he just asked. Yeah. Yeah, when you test the endpoints, you need to show some reasoning why it diverges or converges at the endpoint. You can't just say diverges, all right? You need to justify it. Can't sneeze. That's another one of those, you got it, but it's not enough to actually do it.
That one where you said do not include -3, do we have to put that in our answer? Do not include.
No, you'd have to write that.
But you're just letting us
I needed to
know.
see this diverges.
Diverges. So it's not included in the convergence
Right.
interval.
Parentheses means it's not included.
Oh, that's what that means.
All right, anything else? Another question from the review? Or anywhere else, yes?
Question, what is the
Number 1?
washer called?
Okay.